I'm a twat with the VS project and a goal to build my own game engine to understand the deeper fundamentals of how games work, in hopes that maybe, just maybe, I'll get a job one day. All well and good at the moment, you can walk about, look at the nice scenery, hey, there's even a sword, but you'll soon see, yeah, you can walk through walls, so I might have to fix this. To say collision is a dense topic would be an understatement, but over the next few videos I want to cover some of the different algorithms that are present in it, starting simple and eventually advancing to the more complex shit. Hopefully this will allow progress to feel natural and you'll come away understanding, or at least appreciating, the tech behind every game you've played. Before we get into anything though, one idea we have to understand is that all collision algorithms aim at answering one question. Are two colliders overlapping? The collider being a shape in our world, defining the bounds of an object. So with that in mind, let's get into it. Here we have Axis Aligned Bounding Box, or AABB for short. The name spoils everything as it's just that, a bounding box that's aligned to the axes of our world. It starts by getting an object and computing its bounding box, just a box that perfectly tucks the object inside. We can define this box with a min and max coordinate, storing them for later use. Now to check if two bounding boxes are overlapping or not, we individually cycle through each axis and check if the positions for those axes overlap or not. Let's zoom into the x-axis to see the logic behind this test. Let's lay out the min and max x positions of our two bounding boxes onto the x-axis. We can intuit that our lines won't be overlapping if the min x of our first line is greater than the max x of our second line. The same is true for the inverse, where the max x of our first line is less than the min x of our second line. We can easily combine these two conditions and flip their signs, so that if they're both true, overlap between the lines is present, and we can return true for overlap on that axis. Now all we gotta do is run this twice more for our y and z axes, and if they both return true for axis overlap, we know the two bounding boxes must be colliding. And that's it. Such a simple yet intuitive method for discerning overlap, as we only need a combined total of 6 conditional statements to figure out if our two colliders are overlapping or not. This naturally makes it a good contender for games as it requires such little compute power. Now here's why it sucks. There's two major caveats with this algorithm, the first being that you're limited to just a bounding box. You can't have fancy shapes or anything like that. The other issue with this algorithm is that rotation of these boxes is impossible. That's why it's called axis align, as the boxes must align with the axes. You can see this limitation in games like Minecraft, where if you enable the collider view, the colliders themselves never actually rotate. This is how we can tell that axis aligned bounding box is being used here. This itself isn't a huge issue for simpler games, but those aiming for more precision will suffer using this. This obviously ain't going to be our end all solution to this collider issue, but hey, lucky for us, there's a couple more solutions we still have left to cover, coming later down the line. So until then, cheers for watching and hope to see you next time.